There hasn't really been much progress made on the shard manager or really anything cluster related since the last time we streamed because I've been working on something else, but there should be more progress being made this week since I'm finishing up that other project. But at least we can talk about some of this stuff.
And there has been some interesting additions to the effect core library, at least work in progress, that maybe we can use in cluster,
Hopefully soon.
referring to the
The
mailbox
mailbox
module.
thing, yeah.
Yeah. I think Tim, for those of you who don't know, Tim has been putting in a lot of work on a like mailbox implementation for the effect core library. And it's not released yet, but it's close, I think. And we're probably going to try to leverage that within cluster for the mailbox within entities, so that we don't have to roll our own. May have to like wrap it with a few methods, but um, but yeah, we'll probably try to leverage that within cluster, since it's kind of the perfect use case. But yeah, so as I was saying, I haven't made a ton of progress on cluster since last time we met, but Mike did figure out the performance issue that we were having in tests, at least the last time that we spoke, which was actually nothing to do with the hashable data types. It was actually to do with
Yeah.
the way that sorting happened in the array.sort by or sort with, I forget which method it was. But after fixing that, the tests seem to run relatively well. I'm still um, having a small issue with um, maybe we can open up the tests and I can just show you guys. Um, so if I run the test suite, packages, effect, cluster, of course, packages, cluster, test, thread manager. So these simulation tests still take like a quite a substantial amount of time, 4 and 3 seconds each. So I'm running them concurrently right now to try to like mitigate that. But um, when I was looking into like again, it's kind of hard to debug this a little bit, but when I was looking into where this was occurring, and I haven't quite figured it out yet, but it seems like the issue is happening around the adjustment of the test clock, which I thought was kind of interesting. So I was trying to figure out like how much work the shard manager is actually doing like during the time that the test clock's being adjusted, because like once we adjust the test clock, there's once we do this adjustment, there's a bunch of rebalances that occur, but rebalances are reasonably quick. I think the slowest one that I measured was like only 200 milliseconds or something like that. And I think that's when there's just a ton of things that need to be rebalanced at once. It obviously takes longer when there's more stuff to rebalance. But I mean, I can prove this kind of with our console.time.
Ideally, worst case scenario is every shard is on the frog pod. Ideally.
So, you can see that seems to be like where the time is being taken, like around the adjustment. So like all the like work that's being done within the shard manager could be like taking up this time, or we could have potentially like an issue within the test clock, or we could have an issue within the shard manager. I haven't like actually spent any time looking into this yet, but um, if we look into,
But
sorry, go ahead, Mike.
you mentioned last time that if you were to comment out
Oh yeah, that's
some
right.
fiber forking.
You're right. You're right. You're right. I forgot. If we go into the shard manager, where is it? There it is. So if I go to the bottom, where are you?
Maybe it's still
I'm trying to remember
okay.
what it was. Oh, here we go.
Maybe the persistence of.
No, it's not
Oh,
persistence because persistence in the tests is a no-op, at least for this one.
oh yeah, but it's scheduled if I remember. So maybe it's that is firing as well when you adjust the clock.
Yeah, the pod health. So the two fibers that are running to check pod healths on a schedule and to rebalance on a schedule are actually what seems to be taking up the most time.
Yeah.
So if I disable this, the tests finish like much faster, and then if I additionally disable this, they finish like almost instantly. So I thought that was kind of interesting. Because
Can we check the time now? How much time is spent during the yield?
oh yeah, you mean around the test clock?
Yeah, I mean the console log that you added.
I think I removed it. I'll put it back. Two millis when those things are.
Okay. Can you please just change the test clock uh, adjustment to instead just be an effect.yield? Yield now. Because what I'm thinking is this doesn't really have anything to do with the test clock itself. Rather, this fiber yields to um, whenever you do an adjustment, probably there's some yield that happens, and it gives space to the to the other background fibers to do work, and there can be synchronous work that takes up the 3 seconds in something there. Most likely that's
Let's see.
most likely that's the case.
Um, I mean, how would we go about then? What else do you want me to do within the shard manager itself to like try to?
I would say first of all try to yield a few times because this is still fast. Also, would be probably useful to just enable that single test so we don't have
All
the
the other
rest.
ones.
See if that works. Hang on. I don't know why when we use the effect.only methods, it doesn't seem to. I have to like explicitly skip them. I have to look into that.
I think it depends how you run the tests.
I mean, it turned off concurrent, but
But are you running tests only on that file?
yes.
What?
I only triggered it for this particular file. So, but anyways, okay. So we're only running this test now. And maybe one other thing I can do is let's just break out of this. Um, let's do this. Okay.
Just try to yield a few times now instead of just one.
I mean, right? I still. Do you want me to recomment in all the fibers that are supposed to be running in the shard manager?
Right? Let's try to revert to the test clock adjustment and
The difference.
don't just only enable a few fiber, like one fiber at a time, and let's monitor the time spent in that fiber.
So why don't we start with maybe the rebalance fiber? Let's just. I mean, there's other stuff going on in the shard manager, but this is like the one that takes the most time, so maybe we can just leave that one.
Takes 2 seconds. If you disable this one, it doesn't take that. How does simulate actually perform the simulation? Does it calls rebalance, forcefully calls rebalance, or
No, it just simulate is just a like a helper to for each over a set of events, and handle event just calls the shard manager to register or unregister pods at the moment. There's no other events that
okay?
that are being done. So if we go back to where that's all simulate does. So I'm creating 20 pods right now, registering 20 pods.
Can we log every single repetition of the rebalance with a timed, so at least we know each call to rebalance, how long does it take?
It's going to use the test clock to give us the time, though.
Do I
Well,
recall?
you could just make a quick timed that uses console time, like literally.
Actually, what did I just do? So you want to log the time that the rebalance takes? This fact right here?
Yes.
Okay.
Yeah, and then a tab after that.
Also remember that calling register on register actually calls rebalance.
Yeah, but I mean,
it may be something like when you call register on register, you fork a rebalance, and that uses a semaphore. And I think that maybe that semaphore is kind of being held by too many triggered rebalance processes. Maybe I'm on the wrong path, but
The
if you look at the register and unregister methods of the shard manager, over some conditions, they actually trigger a rebalance. And then they are forked on a different fiber inside of the manager scope, okay? And the rebalance thing uses a semaphore. So I am interested in seeing how many times rebalance is actually triggered. So maybe we can put something like an effect.log inside the actual rebalance method and see, because I would assume that you are doing something like having 20 times rebalance.
I mean, somewhere the time has to be spent.
Yeah.
what do I do?
There's no body in that function.
Oops.
Oops.
Okay, and that's exactly what I was expecting. and we have one at a time because the rebalance should use a semaphore in order to disallow having concurrent rebalances. Also, the rebalance uses a synchronized ref.
Yeah,
So
but just does a get on the synchronized ref. So
yeah,
that's not
yeah,
gonna lock.
yeah, it does a get, yeah, but then everything should be run inside a rebalance semaphore. Yeah, rebalance semaphore with permits 1.
Mm.
So if the rebalance process takes some time, I would assume that basically we are queuing one rebalance call after the other.
Yeah, but if they only take, like, if the longest rebalance takes 200 millis and then the rest are taking like a millisecond or less, like, is this really where the time's being
Yeah,
spent?
Yeah, but I think we
yeah,
have too many
yeah,
console.time with X. Like,
yeah,
that's impossible to know.
Okay, hang on.
I
yeah.
would monitor every single rebalance
Yeah, exactly. We need
call
to time.
instead.
Yeah, so we need to time the rebalance method and see.
No, just
No, no.
inside the rebalance,
Do
Yeah,
you
not
want me
exactly.
to
not
remove
here.
these now?
Yes. We
Basically,
need basically
wrap
to
the.
monitor
Yeah,
each rebalance. And that's not the only thing that calls rebalance. So
yeah.
yeah.
You want me to
That's
Mm,
probably already inside the synchronized
yeah.
just
We basically need, when you do rebalance semaphore dot with permits, we need outside to do something like effect dot timed and see
well,
the total
Or
time.
just this console
yeah,
time.
effect
Yeah.
time's not gonna work, but we could do effect.zip.
This doesn't work because
Mm.
here you are already inside the permit. You want to
Mm,
wrap the whole thing.
yeah.
The best thing is if you extract this whole effect to a variable, like call it const effect, and then just return.
Yeah.
Yeah. So you monitor the whole thing basically.
Right.
Can we also add a counter
Yeah.
to that? Because otherwise I think there's too many.
Rebalance.
Sure. Let's go to
Just when you
Yeah.
call the function basically.
Just use the
Or well,
math.random and use that as number.
like you're talking about like a
right.
global counter that just counts the number of times we rebalanced. Is that
No, I was meaning the
When you log
the issue I see here is that you start basically n times the first console.time, and then you do time end with the exact same label, so they could conflict.
I gotcha.
Every call to rebalance should has its own identifier.
Yeah.
Got it.
So the identifier has to be generated inside the, like, as a first thing. Not gonna work there.
Yeah. You need something like
Has to
effect
be
dot.
inside.
Yeah.
The easiest is if you write a
Why?
generator, and inside the generator you just had
Yeah.
some random thing.
Yeah, that's why I say that you always write better code than me, because yeah, I would have to think about acquire user release and acquire doing console.time and and create an identifier, then in use, perform the work, and then in release.
And then it explodes.
Yeah, but that's the thing you're basically doing, right?
I mean,
Creating an identifier.
Maxwell here is very precise. He's wrapping console time inside an effect.sync.
Precise. I don't.
That's absolutely unnecessary.
It really is. It really is. I don't know why I do this. I don't know why I do this.
Well,
just remove the yield.
yeah.
I will. Give me 1 sec.
Even the math random thing was, yeah.
Well, it works.
It's fine. Return. No, no.
Yeah, you have to yield the effect inside. Yeah.
Yeah.
I think we're just returning void.
Yeah.
But whatever. This is still fine.
Doesn't matter.
Okay.
Give me 1 second.
Now
I
should
just
be
reran this. Okay. Okay. Maybe
okay.
math.random wasn't the best choice.
Well,
Oh, that's fine. Okay.
but it's something that I kind of expected. We have about 400 milliseconds spent in rebalancing, and that would make sense. Because on the first rebalance, if I remember correctly, it won't rebalance the whole thing. It will rebalance just a percentage of the total amount of pods to rebalance. And then the second rebalance would perform the rest of rebalancement. And ideally, after the second or the third execution, we should have a balanced system. That's why the other calls take so little. They shouldn't do mostly anything. Now the thing is how we went from 400 milliseconds to basically 2 seconds. It was the whole time.
4 seconds.
It
Just
was
about.
about 3. Just about 4,
Yeah,
yeah.
2 seconds and a half. Yeah, we are spending 2 seconds somewhere.
Do we do anything
2.5 seconds.
in rebalance? Do we call?
Yeah, but the rebalance calls are timed there.
Yeah.
So
Yeah. I'm just.
Ideally, I would have expected the sum of those times to be almost 2 seconds, something like that, if the problem was in the actual rebalance algo.
Could it be that since we're locking the synchronized ref within a rebalance that
So maybe you can try to move out. You can try to move out the rebalance semaphore from the effect body to your time, but I don't think that that's the issue, because the time.
each single call is pretty fast.
Yeah,
Try to adjust for like
1 minute.
1 minute instead of 10. It reduced.
Yeah. Which is the default configuration for the rebalance interval right now? I don't remember.
um, there it is. This is the default configuration that I have right now.
Rebalance interval 10 seconds. Okay, so let's try to adjust for 20 seconds. It should do something like just to
The retry interval or the regular, just the interval?
the regular rebalance interval is 20 seconds. Okay, leave it 10 seconds, that interval. And in our test, instead of adjusting 1 minute, let's try to adjust 20 seconds. Ideally, we should have only 2 rebalance trigger, ideally. Okay, But why are we
Well,
doing
there's there's
before?
there's other stuff happening like down here, like with rebalancing, which I can comment out for now.
Okay.
It looks like there's many parked fibers, and when you adjust, that means every time the test clock actually has some internal delay. I don't remember how much, but it forces a uh,
And if
normal delay.
now we have three, if you bump the test clock dot adjust to, let's say, 1 minute, we expect to have more rebalance triggered, right? Or should it? I don't know much about the test clock dot adjust, but
It's basically
one issue
just
could be one issue could be that the forked rebalance job was spaced at a fixed interval, and so adjusting for 10 minutes meant that we were rebalancing basically 60 times, and all of those 60 times maybe were triggered basically in the same flash, one after the other.
even if
Don't know
even
much.
if we are rebalancing 60 times after the initial like one or two rebalances here, like it's taking a millisecond to do the actual work of rebalancing. So I don't, even if we do that 60 times, it's only 60 milliseconds or 58 more milliseconds that we're adding to
Oh,
our initial, 2 or 300 for the first two rebalances.
oh.
So
The test clock, every time it suspends, it waits 5 milliseconds, 5 real milliseconds. If you open the test clock.ts file in the effect core repo, there's an effect.sleep. You can just search for .sleep. No,
Oh.
it's with the
oh, it's in the implementation.
lowercase effect. No, the whole implementation is there.
Sorry, one sec.
Oh yeah.
Try to have these at like 1 millisecond instead of 5.
Let me go back to
There is also the same thing, I think, on the same line of the test clock. It waits for 10 milliseconds every time it awaits suspended.
Yes. Oh, it's suspended. There's another .sleep. That's 5 and 10.
And that's 5 and 10. And ideally,
Let's say try 1 and 2.
oh yeah, that seems definitely more faster.
let's actually wait. Let's go back to this and this. Save.
Yeah,
Okay.
Much slower.
yeah.
Yeah.
Not sure if
Why the
if it's fine. Like, the internals of these are unbelievably complex. So
I mean, if we know that the majority of the time is being spent like just by the test clock internally, I'm okay with leaving the tests running for a long period of time until we figure out how to like make the test clock better. Um,
no, but I'm
now we
not
can
sure that
also
there's any reason why the test clock should take this long. I remember there were some tests that were not passing, and I was like, okay, let's give it a few time more. But then we probably had some internal race conditions. Now I tested locally with 1 and 2 milliseconds, and all the tests pass. So
Yeah, it's basically
um
just giving 1 milliseconds of tick to flash whatever is trying to do on the scheduler.
yeah, but then I could just yield.
Yeah. I'm curious if maybe just yielding would work.
I have no idea. Or rather maybe yield to the timer.
Yeah. But well, to the scope of the test, we can assume that if we know the configuration of the cluster manager, the shell manager, we could actually calculate how many rebalance at maximum it would take to actually rebalance the whole thing. So we can, for now, adjust that time to be something that it's reasonable. Maybe 1 minute for me is more than enough. As I said, I think that after the third rebalance, you shouldn't do anything.
I mean, it's not
Because
it's not even saving us much time to change the adjustment at this point. You're still everything. It's 200 millis here, so I think we could probably leave the test alone. Hang on. This is down to a second from 4 seconds. And if I re-enable all the rest of the tests and then turn off all the logging that we added, and I run these concurrently like I was before,
time is always a complex thing.
It is indeed.
I mean, we already shaved off 2 seconds from the test run
Mm.
time just by modifying the test clock.
Well, it makes sense because we rebalance every 10 seconds. So it means that you should perform rebalance about a minute. It should be 60 times, 60 times. Yeah.
I'm not sure if freezing.
Well,
Why is it even doing that?
the good news is that rebalancing and
Yep.
scaling is working.
let's let's
I'm
try to.
hacking around the test clock
Yep.
now to see if
Mike is hacking the test clock. We should like watch him. Probably more interesting than fiddling around with these tests right now.
because I don't even understand why a wait suspended was yielding more.
And more than suspended, yeah, right.
Yeah,
I know if that was some kind of amount decided just to give time the system to do something, I would have expected that to be the same or something like that.
yeah. I mean, I've done something unbelievably stupid, and it actually works. So I
Something like
basically
calling
created.
just the scheduler or something like that should be.
No, I quite literally had a set timeout and a sync effect with a set timeout to 0,
Oh
and
yeah.
I've I'm gonna make a PR and gonna show you how dumb this is.
yeah, steal the screen.
No, there's no point. I'll make a PR
Oh, okay.
in a second, and you can review the PR. That's not so interesting. Uh,
Even today we made effect faster.
At least when you're testing.
At least
at
when
least
you're
when you're
testing.
test.
Well, everyone
Let's
should test,
go.
right?
Allegedly. All right. So That's good. I think that
Test clock.
just looking to see if like so this is the test that scales. Trying to remind myself like the test I wrote. This is the test that's tests scaling up the shard manager from an initial set of pods, adds another 5 pods, and basically checks that rebalancing doesn't happen like all at once, but that eventually the cluster will settle to a fully rebalanced state. Similar test for scaling down. We set up 25 pods, then we scale down 5 pods. We make sure rebalancing is happening. Or in this case, we just make sure that rebalancing happens immediately, because rebalancing should happen immediately for unregistering, right?
I don't remember.
Shard manager.ts
If
unregister.
I don't remember. I think that it should happen immediately only if it sees that there
Yeah.
are unassigned pods.
No, it has to
That
happen immediately for
sorry.
unregistering pods. It
Unassigned.
has to happen immediately, because otherwise you
Oh,
could be
you
left with
assign. Yeah.
shards sitting on pods that have now been
Yeah.
unregistered.
Exactly. Yeah. Exactly.
So
You
this
are basically creating the issue of having unassigned shard IDs. Yeah.
right. So this test is basically testing that when we scale down, we rebalance immediately. So we should have an immediate like settling of the cluster back up to 15 shards per pod. And then this test is basically testing that when we shut down the shard manager, when it actually shuts down, like and runs its finalizers and everything, that it flushes its state to whatever persistent storage is set up. And then we test grabbing the we test essentially grabbing those grabbing that state from storage and making sure that we actually get something back. So clearly there's a lot more tests that need to be added, which I think I mentioned last
Yeah.
time, but this is already a good start for at least the simple behavior of the cluster.
Yeah. No, definitely.
Did I re-enable everything in the shard manager? I actually don't think I did. I did not. Let me re-enable all of the fibers.
By the way, I've just posted a link of the PR.
So this, yeah, perfect. Still taking 2 milliseconds. Let me take a look, Mike. Mm,
If tests pass, I think you can even check with the snapshot, or just base the branch on this.
Yeah. Just I'm not too familiar
Just
with
raise
the
the font a little
internals.
bit.
I'm not too familiar with the internals, but just asking a question that maybe also could use for the viewers. Why don't we use directly the scheduler dot? Is there any reason for that? Because, for example, there are some environment where setting a timeout with 0, the environment is not really happy with.
Well,
Naming one React Native, I know.
why would React Native have a problem with a set timeout?
Using 0 will always, at least in older versions, I think they fixed it recently with Hermes, but in older version they complained about having timer with 0, and they instead forced you to move, warned you more than warned you to move to something else, like scheduler. Don't remember the name of the API, the scheduler task, that API that don't remember the name. I need
Well, the issue is if I yield with the scheduler doesn't really yield the timers.
okay.
So the default scheduler takes, like, maybe I could, well, I could try if it works even with yielding to the scheduler, because then it would be even faster. Uh, but this was a way where basically this is the least, like this is the,
the
before
least
it
worst.
was
Yeah.
sleeping 5 milliseconds
Yeah.
and 10, this is the quickest you can sleep.
Yeah.
And I've erased a little bit more, but now I'm gonna check if everything still passes with what you've just said, because if that's the case, then there wouldn't really be. Let me see. Can do core with fiber.
Again, this was just a curiosity, not on topic, but yeah.
I don't. I honestly have no idea.
Well, it was just because we already have a scheduler which basically is saying I'm scheduling things, tasks, and run them as soon as possible.
On the other side, it can't be cancelled, but I don't think that's even relevant.
Yeah, exactly.
And for people who are wondering what the heck is going on inside the test clock, these methods are all here. Pretty sure they're all here to essentially print a warning to users, like if I think the await suspended. Let's see, I forget from having written this a very long time ago, but I think the idea is that you end up warning the user if, like, in the suspended warning, for example, you display a warning message if a test is advancing the test clock, but the fiber is not suspending, meaning you're essentially just blocking. And I think the suspended does something similar.
So the news is if I use the scheduler, it doesn't work.
Okay.
So it has to be a
Yeah.
timer at least.
Oh well, it's fine.
Yeah, it has to be a timer. I can say with priority 1, but
I was gonna say, if you change the priority of the task, does it help or no?
no, it does not.
Oh well,
It has to be a timer.
yeah, was worth trying.
Cool. Well, I like
But I
this.
mean, you could even sleep 1 millisecond. It doesn't have to be absolutely
Yeah, yeah,
0.
yeah.
0 is fine with me if all the effect tests are passing. Like, if all of the effect tests. I mean, they're all passing, so I'm fine with 0. How fast is this running now? 2 minutes.
Yeah, I mean, even the default scheduler after like 2048 actually yields to the timer with set timeout 0.
Okay, that's fine.
Before we were using set immediate or set timeout based on the runtime, but it generated problems, and set timeout 0 seems to be kind
Yeah,
of
it
the
works.
go-to. But anyway, all the tests work, so we've just made it faster. That's good.
Yep, it.
So it was the test timer at the end.
Yeah.
In the end, it was it was the test clock.
The test clock, yes.
Oh well. We asserted that everyone else work.
It's good to merge. Yeah.
Is that
And
how
I'm
you
gonna
read this?
merge these
Is
before you can
no?
If I can comment.
before you can comment. Ugh.
Is that how you read this? LGTOs looks good to merge. I never read it that. I always read it as
It means looks good to
I
merge.
read it as looks good to me.
Oh yeah, me as well.
I think it is looks good to merge.
I
Should
also
we?
thought
How
that it was.
how many viewers do we have? Can we poll chat? Like,
Oh, oh yeah.
now I'm very curious.
Chat.
I also thought that, but maybe that's my mind that is kind of broken. I also thought also as legitimate.
Yes,
Ah,
that used to be.
legitimate could also be a valid interpretation of this, I guess.
There's many different interpretations. It's let's get these merged.
Let's get this
Let's get this
merged.
money.
Wow.
Looks good to me. I think I'm gonna say let's get this money
Let's get
from
this money.
this moment on.
All right. Let me
Show me the money.
let me. I'm gonna try rebasing again.
Let's cross our finger that our Git overlords doesn't break anything while rebasing.
Please, Git gods, don't at
You
me.
should note that Max is not doing this with screen sharing.
Oh
It's
yeah, yeah, yeah.
out of fear of
Yeah,
messing things up.
yeah, yeah, yeah.
There's a lot of there's fear right now.
Yeah. It's
Why?
saying that
I
it
can
is
feel it.
rebasing, but actually it's just cloned again the repository and just
All
copy
right,
pasting hand
you
by
know,
Yeah, it's
hand the
just
changes.
the first
all right,
the
nerds.
first command was remove minus France.
Fine, fine. You know what, nerds? I'm gonna get
Oh, okay. Finally,
Ah,
some true entertainment. Finally.
all my Git commands. You can all judge me. Git check
looks good to me.
looks good to me. Git rebase main. Yay!
Oh,
My Git
yay!
overlords.
Now the real test, PNPM test, and let's see.
100 failures.
Exactly.
Yeah, really. Uh, okay. I wonder what my diff was in here. Oh, yeah, okay. That makes sense. And then I was
Not sure
going
why for a
to.
moment instead of reading git stash pop, I read git stash poop.
I'm changing my. I'm setting a a shell alias
Git alias, yeah.
right now.
It poop.
All right, great. So we're still
Look how fast it is.
Yeah.
excellent.
It's not. It's not. We're still spending 2 seconds on
Oh, yeah,
scale up, scale
let's try
down.
to run it again. Sometimes it takes some time to spin up.
We can also do.
Oh, no. Oh, but well, before we tested just the first part of the entire test. Now we are testing the whole test again, I think, and that test does quite a few things.
Yeah, but I'm running the simulation tests concurrently, so like these.
Oh yeah, but we are still 1 second, and
Hey, listen,
yeah,
it's still better than what it was before.
yeah, it was 2 seconds off. Yeah, we basically reduced by 30%.
I mean, there is a lot of work going on inside the shard manager during these 10 minutes. And we are forcing a lot of like, I guess,
Yeah, I use less rebalances. I was saying before. Yeah, in 10 minutes.
like it would probably be done rebalancing within.
1 minute, because when we logged before, we have seen that after the third rebalance that it was quickly immediate. So I think that after 1 minute should be okay. Because that is basically based off the configuration. You have the max amount of the max percentage of shards to move each time you rebalance, and
Yeah,
if
after it's triggered 3 times, it
yeah,
should be
because the
rebalanced.
default setting I don't remember what, but should be something like 20 or 25. I don't remember the how much the default setting for. Yeah, you should have rebalance.
My rebalance rate
Rebalance.
is currently
Yeah, exactly.
2/100, which is,
Yeah, exactly.
what is that, 0.05?
Yeah, yeah,
0.02.
0.02? Yeah,
0.02.
that's what I said.
Yeah.
I
0.02.
quite literally add a few zeros before.
That's what I said, Mike. You misheard me.
Yeah.
Okay.
Stupid
Yeah, it's
stupid
it's
microphone.
0.02 0.02 of 300 shards, and in your test you have 20 shards, if I remember correctly.
Yeah, there's 20 shards initially set up, and then in the scale
Yeah.
up test,
There's 20 pods.
Pods or
sorry,
shards? I don't
20
remember.
pods,
Pods, yeah.
20
Yeah.
pods set up in the initial test, and
Okay.
each and 300 shards by default because I use the default
Mm.
config. So it's getting,
Oh, we are also starting the system from no shards assigned to uh, no pod, so that's why it triggers the fast path of assigning everything it can without ignoring the rebalance rate. Yeah,
and I bet
makes
you it
sense.
will do this.
If you first simulate just registering at one pod and wait, and then register 19 pods, it would take more because that setting will kick in and move slowly from the single pod handling everything to 20 pods
Right.
balancing. Yeah.
Well, then we can at least.
Yeah, but I mean, realistically, if we just spend like a second and
Yeah, that's more
1.7
than
seconds, the full test suite takes
3
2
seconds.
seconds,
Yeah.
3 seconds to test more than 10 minutes
Yeah.
of
Of rebalancing.
correctness behavior. I think it's fine.
Yeah,
Like,
yeah.
we can't ask more.
No. I think this is good. And I changed this to be basically essentially one rebalance interval, even though it really could be probably just like 1 second. It just needs to force a tick. Okay, that was a fun detour. I don't really know what we want to talk about today, but
No, I think we got to a good point. At least we know where the slowness was coming from, and we know that there is nothing inherently wrong in the implementation. Again, to summarize a little bit the detour that we've done offline in the debugging last time that we spoke, we were in the process of moving to use mutable data structures, so mutable maps, mutable sets, thinking that there was a huge performance bottleneck coming from there. But upon investigation, we've actually discovered that there was no, wasn't the hash, wasn't the hash at all. The issue was sort width, which was assuming that the function, the mapping function, so basically sort width, array.sort width, sorts an array based on a function, and it assumed that that function was very fast.
Okay.
When in reality, in our case, that function had a cost, and basically with
this was the change that Mike made.
Yeah.
Yes, this was the change, but and this quite literally made it like
an order of magnitude
absurdly
faster.
fast.
Yeah, like
from 3 plus seconds was 200 milliseconds.
Okay.
Yeah, this was like
again we made effect faster. That's always great.
Yeah, and the funny thing is, I've pinged Julio and I was like, "Am I crazy, or this is actually like an order of magnitude faster?" I came back after a while saying, classical type classes and functional programming sucks every time, because basically that order.map input is doing calculating the f. It's gonna be calculated like n squared times. So as if n
it will
is
produce a new
greater,
f for each time it's
It's
called.
not even that it would produce a new f, but at every comparison
Yeah, or the
that f
comparison you
is
put. Yeah,
calculated.
yeah, it will produce a new f
So
every time. Yeah.
so you recalculate it like n squared times, where in this is instead linear. It maps twice. If you have an array of 10 elements and a very fast f, it's probably slower. But as soon as you have any any large array or anything like even a small cost on f, it changes drastically. So this was the reason why
It would take
our
longer. Yeah.
the performance we were noticing a performance hit had nothing to do with
The
the
actual
hash
implementation.
maps,
Yeah.
Yeah.
which I'm happy about, because at least it means I didn't mess up the internals of hash map.
Yeah.
It would have been way harder to fix
To fix those.
than
Yeah.
fixing a sorting function.
Um,
See easier.
let me bring.
And
Okay.
yeah,
Cool.
I think next steps on these are like working maybe a little bit on the mailbox,
Yeah.
and
Yeah.
I don't know, we have to
Once
then link pods to, like, we've done the shard manager pretty much,
Yeah.
or
We need to actually trying to remember in the order of the things I did when I did the first kind of implementation of the alpha.
I think
Uh,
a
I
really
think
good
that we
next
need to
step.
expose the actual HTTP interface or something for the shard manager, because right now we have the shard manager with methods, but we are not exposing that anyway.
Well, we haven't talked about the client interface to the cluster at all yet. So
Yeah.
I would almost argue that we should focus next on, now that we have the shard manager and can use it, we should focus on how entities are actually running
Hmm.
on a given pod. And then once we know, okay, like we can call behaviors within the entities, like entities are running, we're happy with at least that piece, then we can start like arguing about what the client interface should look like and how it should work.
Hmm.
Because yeah, we basically are ignoring that piece right now, and I'm fine with that. We can always like hack it in later. It's just more, I think that the next logical area for us to go, now that we have like the shard manager piece, is to continue working on like the entities and the pod that are running on the pod,
The
because
pod. Mhm.
especially after Tim finishes his mailbox implementation, I feel like we'll have a really nice base for like what the in-memory mailbox should look like. And then we can start talking about like, how that interacts with entities and like what you have access to when you're actually defining a behavior, etc. So
The
and
mailbox. Sorry.
no, sorry, go ahead.
The mailbox that Tim is working on right now, I've seen, is based on something in memory. Do we want maybe expect that mailbox to be something like pluggable with something baking it, or that will be something that then in cluster we will kind of extend and keep something in memory but pull from some storage? The question is, um, do you think that we expect in cluster to have always mailboxes in memory and add persistence as something that happened by side of writing to actual persistence, or instead having a mailbox approach where everything is baked by the persistence? So the comparison is like writing always to the storage and fetching always from the storage, whatever the storage is in memory or an actual database implementation, or having something in memory, and when we also add the persistence, we in parallel persist to the persistence and add into the memory mailbox, and when we pull, we first mark pull and then mark on the persistent that we have pulled, etc. Not sure if I
First of all,
explained.
there is no signaling when you pull.
Oh
The
yeah,
only
right.
signaling
Yeah,
is when the behavior acknowledges the
yeah,
message.
yeah.
So the point is you want to touch the persistence as low as possible.
Hmm.
There's no point in backing everything in persistence, and then every single pull from the mailbox ends up producing an SQL query. That's just like one of the reasons why temporal is slow, it's because they constantly pull the queue, and there's no point for us to constantly pull the queue. We know where an entity is. We should only pull the queue at once, and just to get to the current state. Once we are in current state, we can use the queue as write only, so it's way less intensive.
The only difference I can think of, and maybe I'm wrong, but worth maybe discussing, is that if you have something that is based off in memory, before actually putting new messages into the mailbox, you need first to have resurrected and processed messages into the in-memory mailbox before putting new ones. Okay.
Yeah, that would be part of
And
the
with
pod startup, right?
yeah, exactly. And instead, with something that is fully baked off the persistence, you can have persistence layers don't care about that, because they can maybe already write into the persistence. And if you are up to date with pooling, then you can also perform an optimistic path where the persistence is both in memory and persistent on, let's say, a Postgres table. And if you are not in sync, you can, on the right side, already start writing without having the
The
queue
issue is
already.
you cannot go in parallel anywhere. Like, you can't forward to the local process and persist on the side, because the
Oh
persistence might
no,
fail.
I mean persisting, and then after you persisted, you offer that message to the in-memory implementation. Okay.
Yeah, that means you
Okay.
have a new memory implementation.
Oh yeah. But the thing is that, are we assuming that in-memory implementation is something of an optimization of the storage? Well, the storage, when detects that is up on sync, will start using an in-memory object and persisting. So it will persist and then use the in-memory object, or should we assume that
Well,
they are two completely different things?
the design that we had talked about a while back and that I had like started to write, I think I got pretty far with it, was when a message is received by a pod, that the pod forward will write that message into storage,
Persist. Yeah.
will persist the message. If the message is successfully persisted, the pod receives that back, right, as part of the query response, and then
With a sequence
with a
number.
sequence
Yeah.
number, and then that gets forwarded along to the mailbox, the in-memory
Yeah.
mailbox. And
Yeah.
then the entity that is running has the ability, like now has that message, and depending on what behavior the user has specified, they have the mailbox and they'll pull that message off the mailbox. The only other time that the entity or pod will ever interact with storage, there's only two other times. One is during the pod initialization. When the pod initializes itself, it pulls down state from storage to rehydrate itself, like Mike was saying. And then the other time is when the user in their behavior actually acknowledges or processes that message. We still have to refine that API a little bit. But when the behavior acknowledges a message is processed, that's the only other time that you're
Okay.
actually it's not an explicit write that happens like by by the user actually like marking that message, but those are the only like three places where the storage is actually accessed, and it's all basically write only. The only time it's read is during initialization.
So basically,
And
initialization of the entity or of the pod, of the entity, I think. Yeah, because when the entity starts, it should. Well,
no,
the pod.
I think the pod has to do the first thing to
Yeah.
rehydrate the entities that still have messages to be processed.
Yeah.
So that's the first read.
Yeah.
The second read happens when anytime you receive a message and you produce the persistent, you do the persistence, you get back a sequence number.
Yeah.
Then you
Yeah.
have to check what's the last sequence number that was placed in the in-memory mailbox.
Is the same.
If that sequence number is your current sequence number -1, you can just forward and that's it.
Yeah,
If
exactly.
if there's a gap, then you have to do a pull to be to kind of
To
get
refill the memory queue.
precisely.
Okay. That was my question. We are basically assuming that that kind of thing is performed by the mailbox. It's not something that is aliased away by the effect mailbox, and is the implementation of the storage of the effect mailbox. Okay.
And I assume that when we're doing that check of essentially, we get a message, we write it to storage, we get back a sequence number, we attempt to write that message into the mailbox by checking if the sequence number is the next sequence number, and if it's not, then we need to rehydrate that mailbox again, right? When we do that check, we need to lock the mailbox essentially somehow. We need to prevent the
Exactly.
behavior from reading.
Exactly. And that was why I was asking if that given that kind of behavior could be tricky to, let's say, get right by staying one level up from the mailbox implementation. I would think that maybe that could be something that could be inside the persistence used by the mailbox, and that could be in memory, could be a storage, could be whatever, and then as a cluster user, we just get that because we know that the effort mailbox is baked by providing basically two methods, the write and the get, starting from a cursor. If that's in memory,
I don't think the effect cluster ever exposes the right part. The right part is an internal
yeah, it's an
internal
internal
detail.
Yeah, exactly. It's something that is performed while you offer. While you offer, you have somewhere to persist.
On the other side, let's think about it for a second. If the first thing that happens when I receive a message is persistence, and I get back the message with a sequence number, what would be the case where that message might, well, where the entity is not already rehydrated?
I always
Because
assume.
let me finish for
Mhm.
a second. Because if when we allocate a shard, we lock the receival of messages, which means
Mhm.
we locally enqueue that we have a number of messages to forward, but the allocation process rehydrates all the entities that had pending messages, and only after that process is finished we actually do the persistence of new messages. I don't think there is any case where the entity would not be up to date, because if the entity had no messages, then the new message has to be directly forwarded. If the entity had messages to be processed, those messages have been rehydrated when the shard is allocated. So I think the only gap is
Waiting, yeah.
persistence can only occur when the shard is already allocated to the pod. It cannot occur before the like if we
Definitely.
avoid this race condition, then we don't even need the check, which to be honest might be a better choice, because the allocation of shards, like if the shard is not yet allocated, the entity is not going to be ready to process the messages.
Yeah,
So
even more than the shard allocated is actually the entity spawn up, to be more precise, because if you have to also persist in the in memory queue, that way you have to have the actual in memory queue. Okay, what I always assumed, and maybe my assumption was wrong, that is that if we don't work on that assumption, okay, we can also say that the mailbox storage, that is what makes the mailbox, can actually persist messages without having the actual mailbox instance on hand. If it has
yes,
the
this
mailbox
would be
instance on hand,
immediate.
exactly, it will be, and won't wait for the entity to be spun up and alive. But in order to do something like this, you either have to have a process when you start the entity and create the entity that ensures that before putting new messages inside the memory queue should be up on point where the last insert was, or you demand that aspect to the actual mailbox itself. Okay, and without thinking of cluster or whatever, you can be something called mailbox that basically has an offer method that puts something on a queue, and a take method that takes something from a queue. Okay,
Yeah, but
and
you're just moving where the synchronization happens.
yeah. Basically, I'm just
That's not the
moving.
point.
Yeah, I'm moving that away from the actual mailbox instance and rather to a persistence.
We had this discussion in
Yeah,
Discord,
yeah,
and when you went through the details, you realized that you were just moving one problem from one side to
yeah,
another.
yeah,
Doesn't change anything in this discussion.
yeah.
The point is either do you persist as soon as you receive the message, or can we afford to wait for the cluster for the
For the
shard to be in
entity.
sync?
Yeah,
Because if the shard is in sync, all the entities within the shards are in sync, and then it's an easy path. We
yeah,
don't need any kind of synchronization.
yeah.
On the other side, if we want to persist on the fly, then we might have race conditions to manage.
And
Assuming that the shard allocations don't happen every second, I think it would be a safe assumption that the majority of the time we have shards ready.
yeah,
The only risk is we might lose a message, but if we lose a message, it it it's basically on a crash. If the process crashes, but if it crashed a millisecond before, we would have lost the message anyway because it would
yeah,
have not been received, and everything is idempotent, so the sender can easily
yeah.
retry.
The other moment when we could lose a message, but that could be more a timeout than actually losing a message, is in the situation when you, for some reason, a large amount of entities on the same shard spawn up, and the actual hydration of the entity takes more than the right side accepting messages. So that way you should lock them until you have the entity, as we discussed, and then you would take more for the actual entity to receive the message. Let's say that you have a system that is completely empty, and for some reason uh, all the entities that are receiving messages are on one shard. Okay, because you are basically bloating a lot of messages. That could be also a situation when the amount of time that takes for the entities to be spun up is greater, because you are basically sending a lot of messages that are targeted on a specific shard ID. Yeah, but those are the only two situations that are pretty rare to.
No, I mean, the second situation just means you have to increase the number of pods because you have too many shards
Yeah,
on the same pod.
yeah.
Takes too much, and it
It,
got to the
it's
point of the cluster being
yeah.
non-operational.
It's
Because
the trigger that.
keep in mind that the time you only have to fetch non-processed
Yeah,
messages. So what it means if you get to that situation, that you enqueued so many messages before processing
yeah.
them
Mhm.
and crushed before, which is a pretty odd
You're basically putting
circumstance.
yourself in the situation that you're about to reshard the system, because you are basically, you have put yourself in the situation that when you don't have enough shards and you need more
And
shards to try to rebalance more the system. Yeah,
I think to an extent this links to another point that I wanted to make, because Maxwell mentioned the client protocol, and I've been thinking about it for a while. I don't I don't think we can afford to have at most once in the interface, because I cannot find any way where the client can know if a message is just lost, non-processed, and or it's waiting for a response. I think we should assume that all the messages are at least once and idempotent, and anytime you do the send, you wait for the response. If we want to do an at most once, then it's quite literally the client has to, the behavior has to deduplicate the messages,
Yeah.
basically has to
Yeah.
handle idempotency.
Yeah.
And I think that's it's the only reasonable choice where
Yeah.
we don't make too many assumptions on the client.
Yeah, it's the one we basically always started with, saying, but let's say that we force the client to send the message until it gets a response that it may not be the actual response of the message being processed, but just saying, okay, I received. And then it's
Yeah,
up
but
to you.
that's a tell. For that
Yeah,
interface, you
yeah,
can do a tell and just not wait for the receiving. That's fine.
yeah,
But the issue is if you do an ask, you're then waiting for the response. But what happens if the behavior got the message, acknowledged the message, and then crashed?
yeah,
That message will never be processed. You'll
yep,
never have the result.
yep,
But how do you know? The message could take a minute. The message could take 5 minutes
yep.
to process. Where do you put the line on saying, okay, the message is no longer processed? And if it's not, what do you return? Do you return an error
In some
or
The
respects,
only
something that
thing
was
that you can
expected?
do, the only thing you can do is just let the client decide how much you would wait to get response. Maybe the client would do something like pull, and the client will decide, I will pull for, let's say, 10 minutes, and after that, okay, the client will say not processed. But again, it's at most once.
in some
The
respect,
client wouldn't know if actually got processed or not.
I think in some respects that also makes it easier for us to design a client protocol like that makes sense with the way that we're planning on doing behaviors as like long running fibers that never end. Like I think it makes it easier for us to actually design a client protocol that makes sense if we plan on at least once processing, and just make that like the only way.
Yeah.
Yeah, I mean, I just think we can't cover all the cases with also including an at most once, and those are things that if they go wrong, then you just have a client waiting for eternity, and the cluster could, like, if you think one entity pinging another entity, if that message then gets stuck, you have a whole
Cascade of things.
chain
Yeah.
cascading. It quite literally brings down
Yeah. All the whole
the whole
thing.
thing. If the assumption is every message has to be processed and an answer has to be given, even if it's like the answer could take 2 years, an entity could decide that a message takes 2 years to be processed. That's completely fine, and not acknowledge and not process it. But then the client knows, okay, I'm having to wait 2 years to
Because
get
that's
that.
expected time to get
That's
that
the
message. Yeah.
expected thing.
Yeah.
You always have an expected response. So you basically don't assume a timeout, and even
Mm.
if the whole thing dies and it restarts again, that's fine. It's gonna take 2 years. uh, Now obviously that's not the default condition.
Yeah.
Probably all the messages will be processed quite fast, but
That could be
the
one
point is
situation.
there's no my point in my thinking was, I there is no way we can enforce a timeout
Yeah.
while also allowing for long running processes, because they kind of go hand in
Yeah.
hand. And this, by the way, it's something that other workflow engines have, which is like, there are some workflow engines. I'm doing a comparison between different types of workflow engines. There are some workflow engines where you have a server that calls you,
When
versus
you're ready. Yeah.
like Temporal has a similar design to us to an extent. They have workers, and the workers constantly pull a queue, which is what makes it slow, by the way. By clustering, we don't have that problem. For us, the queue is mostly a write only scenario, but they can handle long running processes because it's the worker that knows when it's done. Things like ingest or restate, they have a server that calls you via HTTP. So you can deploy your workflows like serverless functions and so on and so forth. There's no way that those workflow engines can support long running workflows, because they would have to initiate an HTTP call, and that could time out.
Yeah.
And you cannot, there's a configuration that says, okay,
This is
all
the
my
max amount of
workflows
time.
have,
Yeah.
this is the maximum amount of time that I'm allowing a workflow
To do something. Yeah.
to live for, and they need that because they call you, and they don't, but they basically have to decide at some point, is the serverless thing dead? Am I gonna keep waiting, or am I
Or
just
is
gonna
it
stop?
normal that is just performing work?
Or is it
ethics, right?
normal that it's an undecidable,
Yeah.
it's an undecidable problem?
Yeah.
uh,
You
so
cannot
I
assume the
think
timing of anything. It can be 1 millisecond. It can be 200 years. You don't know.
that's exactly the point.
Okay,
And
sorry guys.
if
Unfortunately, I have to leave. Sorry for interrupting. And
thank
see you
you for
next
having
time.
joined.
Commentia.
Bye bye.
See you soon.
See you soon.
Sorry for derailing
No,
the conversation a little bit,
I think that was a good
but
conversation. I think that I'm just like no pun intended, ingesting the whole at least once. I think it makes a lot of sense to make that what the supported messaging like protocol is going to be, like at least once, always in Tempeton. You can be guaranteed that your message is going to get a response, whatever whether you're asking or telling. Like if you're asking, you're going to get the response that you expect, unless the thing dies, and you'll be notified. Like I think that makes a lot more sense.
and if you're telling, you just get the response back. Well, not the response, but
When the
you
message is
get the
processed,
completion of the effect when the message is
persisted,
persisted.
right?
Yes, because tell doesn't wait.
Right.
In tell, you basically, I'm telling you this. As soon as I'm sure that you will get the message, I'm done, I'm fine. And even the signature of a tell doesn't contain the response, it contains a void, basically.
Right.
Gone, fine. Or rather, maybe I don't know what it could contain. Actually, a void, because given that we have idempotency IDs, you can always pull the state of a message by its identifier.
Right.
So we have basically three methods. We have ask, tell, and poll. Ask waits for a response. Tell doesn't wait for the response, wait for the delivery. And poll retrieves the current state of the message. So it tells you it has been processed, it's not yet been processed, or basically just that,
Right.
or it doesn't exist, or I've never received this message whatsoever. One is a read-only thing, the other is a send-only, a write-only thing. The ask instead is a read-write. So it write then reads.
Yeah, I think
this simplifies the thing.
I also think it makes it. I mean, personally, I think it makes it more robust for the type of system that we're after. Like again, the points you made about like we're looking to support long-running workflows as well. Like I think it just makes more sense for the type of system we're trying to build.
Yeah, I mean, if we think about it, really the reason we are even building cluster is because we want to support any type of durable computation to occur. We want to support plain workflows a la temporal, which are short-lived transactions. We want to support state machines that may span for years, and they may never end. You have a state machine, you query the state machine, you interact with the state machines. They're just actors, and
yeah.
this type of flexibility is really the differentiator between our solution versus the other types of solutions. Other types of solution prescribe a single type of workflow to occur. Again, ingest, restate, they're fantastic. They're very easy to use. They are very nice. They already have commercial products to some extent. It's much easier if you just develop a server that calls HTTP calls, and your workflows are just repeated HTTP calls. You don't have to coordinate clusters or stuff like that. Or you have on the other side stuff like Golem, where your runtime is different. They have a custom runtime, and everything is serialized. There's on the side persistence. That's also very prescriptive, because can you do a state machine in that? Sure, you basically implement a local reducer, and you consider the function invocations like, updating the state. But what happens when you want to update the code? You have to make a new code, and you have to replay everything from the beginning,
Right.
which is really not what you want in a state machine behavior. Because if that takes, I don't know, 100 messages per minute for a year, it's going to take a while to replay the whole history, if you want to do a bug fix in an action. And for those types of workflows, explicit state machines are just better, because you have your state. You can update the state with a normal database transaction, and you can update the actions just by changing the code. But updating an action doesn't mean you want to replay from the beginning. Let's say, for example, I don't know, you have an action that ends up calling Stripe, and Stripe changes an API. Just want to change the API code. You don't want to
Right.
replay all the calls from the from the history of time just because you had to update the code. So there's pro and cons of every solution. I think ours is kind of the most complete. What it assumes, on the other hand, is you have at least one or two processes, long running processes, that don't basically, you can't host that in a serverless environment at the 100%. You need at least a few coordinators. Uh, if you have the few coordinators and you want to deploy everything in a serverless environment, if you think about it, you could create one actor that just calls an HTTP API, and then you can host the workflow in the HTTP endpoint, and you basically have a restate like solution. Or you can host your workers by yourself with persistent processes, and then you have a temporal like solution that can also do state machines and other stuff. So I think our objective is really to cover the workflow execution element, or rather, not even workflow, the durable computing element. It's not like, that's the key difference between Effect Cluster and Shardcake. Shardcake was just sharding data processing across nodes. Our use case is different. For durability, you really want everything to be idempotent. Everything, like, the golden path should be that. It Maybe in a year time we find a different solution for at most once, and we decide to re-implement it. But at least at the beginning, we should put users in the golden path.
Yeah,
And idempotency, repeated transactions are really the golden path here.
I agree. I agree. It also makes my job easier since I have to work on it. So I'm happy with that. Um,
Good.
cool. Well, hopefully next time we won't be working on test clock the whole time.
Yes.
But yeah,
Now we reactively start hacking into cluster.
yeah,
Because you,
exactly.
you had to work a little bit on the beautiful CLI,
Yeah,
which will
which
be announced soon.
yeah, users will get access to that soon. TM.
Soon.
Cool. All right.
Good, good.
Well, thank you very much, Mike.
Thanks to you. Speak soon.
Cheers.
Bye, folks.